Solving for a specific value. Many times you'll see an equation with more than one variable in it, and they're going to ask you to solve for one specific variable. And you're going to do this applying the addition, subtraction, multiplication, and division properties of equalities. Now, this problem here is going to ask us to solve for y. So I want to get y all by itself. I'm going to do any adding and subtracting first. That means if I want my y all by itself, I need to move the 3x over to the other side. I do that by doing the opposite. The opposite of positive 3x is negative 3x. And what I do to one side, I do to the other side. Oops. This creates a 0, leaving me with negative 4y equals 7 minus 3x. I cannot combine these because they're not like terms. One has a variable x and one does not. Now, I'm still trying to isolate my y, and in doing so, I need to separate it from the negative 4. It's connected through multiplication. The opposite of multiplication is division. So I'm going to divide by negative 4, leaving me with y equals 7 minus 3x divided by 4. I can't solve it any further, so that's what I have. Oops, I forgot negative 4. Now, I can simplify, and what that means is I can't have a negative in my denominator. So I'm going to take the problem of 7 minus 3x divided by negative 4, and I'm going to multiply everything by negative 1 using the distributive property. Negative 1 times 7 is negative 7. Negative 1 times negative 3x is a positive 3x divided by negative 1 times negative 4 is a positive 4. So therefore, y equals negative 7 plus 3x divided by 4. I can also rewrite it as 3x minus 7 divided by 4. A lot of teachers will tell you to write that like that because usually you put the variable first. In our next problem, we're going to solve 15 equals 3n plus 6p. And we're going to solve for n. I'm going to highlight the n. That way I know what I'm solving for. I'm going to do all addition and subtraction first, moving everything over that I possibly can over to the other side. The opposite of a positive 6p is a negative 6p, and what I do to one side, I do to the other side. I have a negative 6p positive 15 equals 3n. I need to separate the 3 and the n. They're connected through multiplication glue, and the only thing that will separate them is dividing by 3. And I divide this whole thing by 3. That equals 1. N equals negative 6p positive 15 divided by 3. But I'm not done yet. And the reason I'm not done yet is because I can divide 3 into 6 and I can divide 3 into 15. So I need to simplify the problem. If I had this separated, if I said negative 6p divided by 3, negative 6 divided by 3 is a negative 2p. And 15 divided by 3 is a positive 5. Please don't forget to simplify your problem, because most likely your teacher will mark it wrong or take points off if you don't simplify. Let's go on to number 3. K minus 2 divided by 5 equals 11j. Solve for K. I'm going to highlight my K. Okay, the first thing I'm going to do is I'm going to come down here and I'm going to rewrite my problem so I have enough room. K minus 2 divided by 5 equals 11j. I'm solving for K. I need to get rid of my fraction. The only way I can get rid of my fraction is to multiply both sides. See, the K minus 2 divide by 5, the opposite of division is multiplication. That makes a 1, kind of a slanted 1, but it equals 1. 5 over 5 equals 1, leaving me with K minus 2 equals 11 times 5 is 55j. Now I can add and subtract. The opposite of negative 2 is positive 2. Bring down my K. This equals a big fat 0. Equals, now I'm not going to add them together, add the numbers together, because one has a J and one does not. Those are not like terms. So I'm left with 55j plus 2. On to number 4. Here we're going to solve an equation for a specific variable. Again, notice I have that variable on both sides. 2m minus t equals sm plus 5. And they want me to solve for m. I have an m here and I have an m here. Before I solve for m, I have to make sure all my m's are on the same side. In order to do that, I need to combine like terms. So, let's get moving. Okay, step 1. I need to move this over to this side. A lot of times I like to move left over to right. The opposite, I'm not separating the S and the M. The only thing I'm doing is moving it over the other side. So the opposite of a positive SM is a negative SM. And now I'm left with 2m minus sm. I can't combine these because, even though they both have m's, this has an s and this does not, so I cannot combine it. Minus t equals 5. From here, I'm going to move the t over to the other side. The reason I'm doing that is because I want just the m's on one side of the equation. The opposite of a negative t is a positive t. That's why I put a little curve by the t, because it looks like a plus sign. I'm going to bring everything else down. 2m, negative sm, negative t and positive t create a big fat 0, equals 5 plus t. Now I have my m's on both sides. Like I said before, they're not like terms because one has an s and the other doesn't. What I can do is I can do the distributed property backwards, meaning I can take out an m out of both of them. So I can divide this by m. And when I divide this by m, my m is on the outside. That cancels out. I'm left with 2. That cancels out. I'm left with a negative s equals 5 plus t. Notice, if you look at this, if I said m times 2, I get 2m, and m times negative s, I get negative sm. What I did was I did the distributed property backwards. Oh yeah, I already said that. Okay, now, this is in parentheses for a reason. The reason it's in parentheses, A, is because that's what's left over, and B, it's still connected through to the m. How is it connected to the m? It's connected to the m through multiplication right here. Well, the opposite of multiplication is division. I want to divide by 2 minus s. And what I do to one side, I do to the other side, because 2 minus s divided by 2 minus s equals a big fat 1, leaving me with 1m equals 5 plus t over 2 minus s. And that's exactly what I did. I solved for m. Even though we already solved for m and we can't solve for m much further, remember, on the bottom of a fraction, I cannot have 0 because this equals no solution. So although I have 5 plus t divided by 2 minus s, what would I substitute in for the s to make it the denominator is 0? If you guessed 2, you are correct. So I'd have to add to my solution that s cannot equal 2 because 2 minus 2 is 0. Okay, so anytime you have a variable on the bottom, figure out what would I plug in there that would give me 0. And that's what it can't equal. Okay, let's go on to the next one. D plus 5c equals 3d minus 1. Solve for D. Whew. Okay, I think we can do that. I'm going to use my highlighter. And I have a D here and a D here. I need to get all my D's on one side. So let's go ahead and move the smaller d over with the bigger D. The opposite of a positive D is negative D. And what I do to one side of the equation, I do the other side of the equation. Remember, there's a 1 right there. Positive D and negative D equals 0. Plus 5c equals 3 minus 1 is 2d minus 1. Now, my d's not all alone yet. I still have a negative 1. So I have to move the 1 over to the other side. The opposite of negative 1 is positive 1. I have a positive 5c and a positive 1. I cannot combine them because they're not like terms. One has a c and the other does not, so I can't combine them. Equals 2d, and that is a big fat 0, so I don't have to solve that. Now, I still have the 2 connected to the d. It's connected through multiplication glue. Okay? It's a clear glue so you can't see it. The opposite of multiplication is division. So I'm going to divide both sides by 2, and I'm left with 5c plus 1 divided by 2 equals d. On to problem number 6. 6q minus 18 equals qr plus s. Wow, we got 3 variables there. We have a q, we have an r, and we have an s. Okay, what's it want us to solve for? It wants us, get my highlighter, wants us to solve for q. So I have a 6q and a qr. I need to get everything on one side. That means I need to do 2 moves here. Okay, what I'm going to do now, and you can move the 6q over to the other side or the qr over to the other side. It doesn't really matter. I'm going to go ahead and before I move any q's, I'm going to move the 18 over to the other side. So I need to do the opposite. The opposite of negative 18 is positive 18. I'm left with 6q. This equals 0 equals qr plus s and plus 18. I cannot combine the 18 with the q, the r, or the s because none of them are like terms. They're all separate, different variables. Now I need to move the qr over this side because I need the q together. The opposite of positive q is a negative q. I'm left with 6q minus qr equals, it's a big fat 0, leaving me with s plus 18. I cannot, even though these both have q's in them, one has an r and the other does not, so they are not like terms, so I can't combine the coefficients. What I can do is I can remove a q from both of it. So if I were to say, divide this by q and divide this by q, the reason I'm dividing is through multiplication. Okay, I'm left with a q, open parentheses, cancels, leaving me with a 6 minus equals 1, cancels, r equals s plus 18. Notice I'm rewriting my whole entire problem. Now my q is connected to the 6 minus r, in parentheses, it's as 1 unit, is connected through multiplication. Now I can divide by 6 minus r on one side, and I can divide the other side by 6 minus r. I didn't divide both sides of the equation here because I just wanted to remove the q from the 6 and the negative r. Okay, here I want to actually separate the q from the 6 minus r. So that equals 1. I'm left with q equals s plus 18 divided by 6 minus r. Notice there's only addition and subtraction, so I can't reduce the 18 and the 6. Okay? It says 6 minus r. If it was just 6, then I could reduce. But since it's 6 minus r, I cannot reduce. Here's another one, a formula. The formula of circumference. C equals 2 times pi times r. And they want us to solve for r. Well, how is the 2 and the pi connected to the r? It's all connected through multiplication. The opposite of multiplication is division. And when I do to one side, I do the other side. I want to divide or remove the 2 pi from the r, leaving me with c divided by 2 pi equals 2 pi over 2 pi equals 1. I solved for my r. I'm done. Problem number 8. Volume equals length times width times height, and they want us to solve for w, or solve for the width. Once again, how's the length, width, and height connected? Or I should say, how's the length and the height connected to the width? It's connected through multiplication. The opposite of multiplication is division. And since it's all connected through multiplication, I can do it in one large swoop and divide, because L over L and H over H, I'm left with volume divided by length times height will give me my width. Now I have a problem. They want me to insert numbers into my new formula. Find the width. Notice the width is all by itself of a rectangular prism that has a volume, or V, of 79 4/100, a length of 5.2 centimeters, and a height of 4 centimeters. So I'm going to substitute these numbers in for my variables, hence solving for my width. My V is 79.04 divided by my length is 5.2 and my height is 4. And that will give me my width. So let me come down here and get my calculator out. Set it to equal. I have, first I'm going to multiply 5.2, well, that's 52, 5.2 times 4. Okay, so now I have 79.04 divided by 20.8, or 8/10. Okay, now I can divide. And 79 4/100 divided by 20.8. Click on the equal sign, and my width is 3.8. If I were to take that all together and plug it into my original problem of V equals length, width, height, I would have 79 4/100 equals my length is 5.2 times 3.8 is my width, and my height is 4, and they would equal each other. 79.04 equals 79.04. Okay? Let's move on to another problem. Don't be scared. The formula S equals 1/2 times A times the square of t represents the distance S that a free-falling object will fall near a planet or the moon in a given time t. In the formula, A represents the acceleration due to gravity. If you have no idea what that is talking about, you have to only know one thing. The variables. Okay? So all you care about is the variables. What are the variables? Represents the distance S. S is distance. And T is time. And can't find my cursor. A is acceleration. It's all you need to know. Okay? Now let's go on to A. Solve for A. If I have S equals 1/2 AT squared, the first thing I need to do is get rid of the 2. Not really get rid of it, just simplify it. The way I do that is I multiply each side by 2. Multiply everything by 2. So 2 times S will give me, draw an arrow, 2S equals 2. See, that cancels out. 2 and 2 cancels out, leaving me with 1. I don't have to write the 1. Or AT squared. I'll write the 1. Okay? I still have the A there. It's connected through multiplication by the T squared. So I'm going to divide because division is the opposite of multiplication, leaving me with 1A. So A equals, and all I'm going to do is I'm going to flip these. Move the A to the other side and the 2S divided by T squared to the other side. That's all I did. I switched sides. Okay? Hence I solved for A. Well, on part B, they want me to plug numbers into these formulas so I can solve for the acceleration. So let's go ahead. What's S? S is distance, T is time. Get my highlighter. A free-falling object near the moon drops 20.5 meters. Is that time or distance? That would be distance. So this is my S. In 5 seconds, that would be my time. Okay, now let's go back and plug in. A equals 2 times my S is my distance, which is 20.5, divided by my T squared is my time. So that's 5 squared. Bring up my calculator, and I'm going to plug in 20.5 times 2 is 41. So A equals 41. And 5 squared means 5 times 5 or 25. And if I were to divide this, I would get 1.64. Okay? And that's all there is to it.